Hello and welcome to our project demo. My name is Mohammed Sabag and I'm a developer with Bugbusters. Today we are going to present to you our multiplayer web application GameHub. Let's start with a project overview. The objective of our project is to create a GameHub web application where users can create an account or play as a guest if they wish, and they can select turn-based games to play against their friends. So far, we have only two turn-based games, Tic-Tac-Toe and Connect 4. We have also implemented a chat window between players to allow them to communicate with each other. The games are designed to be as simple as possible, and truly anyone can pick up a game and play in their spare time. We anticipate that the largest demographic is going to be teenagers and young adults who enjoy playing games with their friends. A quick scenario is that imagine you and your friends are on a Discord call together. Everyone has some varying amounts of hardware. Some people have strong computers, some have modest laptops for school, and some only have a cell phone. As long as all of them are able to connect to the internet, they can easily play against each other using our application. The principles of our project are modularity, separation of concern, and anticipation of change. Firstly, our project is modular. We have few games, but each of our games is independent of the other, and games can be added, swapped, and removed without affecting the rest of the application. Next is the separation of concern. Our software is split into front and back end. For the most part, everything remains separate. Lastly is the anticipation of change. As previously mentioned, games can be swapped without disrupting the overall function of the application. And if the game hub itself needs to be changed, the games within the hub are not affected. Now, to demo the project and the different features that we have, I will leave you with our team.
The first feature we are going to demo is Tic-Tac-Toe, which we can access through GameHub. So we can pick Tic-Tac-Toe, and we can first sign up or sign in into an existing account. So for the username, you can put anything, password. Once you sign up, you'll be assigned the profile picture you chose and also the user number. And for Tic-Tac-Toe, we can play against AI or multiplayer. We'll first demonstrate playing against the AI. So when I make a move, the AI will immediately make a move, and I cannot overwrite existing moves. And I won. And the winner is displayed in here. And we can see that after winning, like, we can no longer make moves on the board. So another feature we have for Tic-Tac-Toe is multiplayer. So to demonstrate the multiplayer functionality, I have Duck here with me, and I can click create room. Oh, he's logged into a different account. Once I create a room, I can see the room number, which is 55, and he can join using the join room button. And we can see that once I make a move, even though he's on a different machine, it shows up immediately, which demonstrates live playability. And when he makes a move, it shows up on my board as well immediately. And each play's turn is indicated down here. Oh, we tied. And yeah, once we tie, we can no longer click over the board, and the tie is shown here. So that is our first feature, Tic-Tac-Toe.
For the second game we are going to show, it is called Connect 4. The game, the room functionality is the same as Tic-Tac-Toes. So we will just create a room and then our friend can join. The room number is 11. Join me, my friend.
Yes.
Okay. So the rule of the game is very simple. We just click in one of these buttons to drop one of the circles. So it will fall down like gravity, how it works. So the goal of the game is to obtain 4 in a row of the same color. I mean, optimally, it should be our color. Yeah. So, well, my friend can also will play her turn, and then it's my turn, then her turn. Yes. So
Are you not
when we
blocking?
get 4 in a row, the player who gets 4 in a row first will win. So it is either 4 in a row or 4 in a column or 4 diagonally, but they need to be in the same, like close together. Yeah, and when we win, we cannot move anymore because we already win. No, they win, but
Hello there, my name is Stephen Clark. I am a team member of Bugbusters, and today I'm going to be demoing the chat feature. So here I have 2 instances of our application. The first one is logged into the account Stephen1, and on this account, I'm going to create a tic-tac-toe room. And on this account, Stephen2, I'm going to join the room indicated by room code 85. And here's our chat feature. It's a simple text box with a submit button. So for instance, let's say I type a message here. It's sent from Stephen1 and it appears on both this instance and the other instance. And I can type on this instance as well. And you can continue playing the tic-tac-toe game as normal. Until someone wins, and you can still send messages after the game's over. So a couple things to note here is that you cannot send a blank message. So if I try pressing this button when no message, there's no content here, nothing will happen. You also can't send too long of a message. So if I try and spam here and then copy it and paste it a couple times, that won't work either. You're also able to send non-ASCII characters. So as an example here, I have this icon from a font called like Nerd Fonts. And this is a Unicode character with a very large Unicode number, definitely not ASCII. So if I copy the icon here, you can see it appears kind of weird in the text box, but if I press send, it still does send properly to both instances. And another thing is that this is safe against SQL injection. So if I try doing something like semicolon, drop table, users, semicolon, comments everything after, it just treats it as plain text. So that is the chat feature.
I'm Sebastian, and I'm going to discuss the architecture used in our project. We decided to implement a microservice architecture which aided in splitting tasks and user stories into their own particular module or component, allowing our group to split up into partners to easily develop features simultaneously. Furthermore, by using a microservice architecture, we remove redundant dependencies. For example, consider a game such as Tic-Tac-Toe, which uses the chat service to display messages between 2 players. In the event that chat service is not working as intended, any tic-tac-toe game may still be played without crashing from a chat service failure. Typical flow of data through our architecture begins with the client, who interacts with any front-end web component. The web component will then send any related request to the gateway API, which forwards any data to the requested backend service, for example, chat service. From this point, chat service will operate on the data received and return a response, which travels back through the gateway API and back to the web component, which handles the reply accordingly.
Okay, so we are going to talk real quickly about the workflow that we had in our team. Basically, we had a GitHub repo that everyone are assigned to it. We have many more branches that were made, each as designated for a specific feature. The naming conventions we will see later is what we agreed upon as a team. We also know that there is protection on the main and staging branches. Those require reviews by different developers to make sure all the developers who are pushing to it are using proper naming conventions and they're not pushing garbage code. We see here on the pull request, we already have 20 closed pull requests and we have still 5 open. And at the end of each iteration, we push staging into the main branch. We also have a continuous integration set up with GitHub Actions. So it runs auto testing for every time someone makes a pull request or changes upon it and commits to it, we can see here that we'll have 120 workflows runs already. And the way we split up tasks is that we used prioritized backlog here. This is using GitHub projects. For each user story, we have at least 2 developers to encourage pair programming. Basically splits up the tasks into smaller and doable tasks. Finally, we're going to take you over to our main source of communication, which is using Discord. You can see there's 3 voice channels since there is 6 developers on our team. Usually there is 2 in each of them working on the same developer story. And since we're here, we're going to look at the conventions that we had. We had branch conventions, branch naming conventions. We had other naming conventions that we needed to follow as well. While programmers were working on pair programming, they realized that there was some problems or difficulties pulling up, pushing codes. It doesn't even allow them to work together. So an easy fix to it is using the VS Code Live Share extension. This allows 2 people to work on the same file without having to push or pull simultaneously. And while we're here, we also can show you that we had issue templates for bug reports, feature requests, and user stories. And this basically sums up our workflow for the project.
To know whether if our product is worth investment, we have to analyze the market. As of 2023, there are 3 billion gamers worldwide. The increasing number of gamers don't see a sign to stop as more kids will join in on the fun. Moreover, with the global online gaming market projected to exceed 200 billion by 2023, our total accessible market extends to a significant portion of internet users worldwide who enjoy gaming as a pastime. Our serviceable available market narrows down to users who are teenagers and young adults. They want to play without having to download anything for convenience sake and have the ability to chat with friends while playing. Since we are based in Canada, we would like to target the Canadian population before expanding to broader markets. Marketing and operational costs will be lower, and we will use the local market as a testing ground as well. Canada is home to approximately 7 million individuals aged 10 to 24, presenting us with a substantial user base to tap into. Furthermore, a striking 85% of Ontario high school students have reported engaging with video games in the past year, underscoring the robust potential of our serviceable available market. Our platform is poised to meet the gaming and social needs of this tech-savvy demographic, paving the way for a strong foothold in the Canadian market before scaling globally. Assuming 1 to 2% of our serviceable available market is using our product, there would be around 120,000 users. The number of users will continue to increase after our launch due to marketing, and since GameHub is a very social platform, it naturally encourages word-of-mouth promotion between friends. We plan to run banner ads and offer paid memberships, and our revenue is estimated as follows. Using Google AdSense, with around 88,000 monthly page views for a North American gaming website, we could earn around $4,600 per month. We have a lower figure for our monthly page views since one of our perks of our monthly subscription is an ad-free experience. Additionally, if 15% of our users decide to purchase a $4 monthly subscription to our service, that would be an additional $70,000 per month. We think $4 is reasonable price for a monthly subscription, seeing as with our competitor Plateau, which will be elaborated on later, $4 gets you 4,000 coins, which is enough to purchase only 1 to 2 cosmetic items for their profile pictures. One of our main competitors is Pogo.com, which is an extension of EA Games. It positioned itself as a popular destination for web gaming, primarily targeting teenagers. However, the platform lacks real-time in-game chat, a feature that many users expect today for our social interaction and engagement. This presents an opportunity for us to differentiate by offering a more robust and interactive communication feature within our games. Additionally, while Pogo.com offers a range of games, some of the more premium experiences are locked behind a paid membership model. Our approach is to provide a more accessible gaming experience without mandatory fees, which could appeal to users who are hesitant to commit to a subscription. Not purchasing our membership does not reduce the range of user experiences, as all of games are free. Lastly, users have reported that Pogo's mobile experience is less than optimal. Recognizing the growing trend of mobile gaming, we have invested in ensuring that our mobile version is as seamless and user-friendly as our desktop experience, guaranteeing that our users can enjoy their favorite games anytime, anywhere, without compromising any quality. Another competitor is Plateau. An app download is needed before any games can be played. This requirement can be a barrier for users seeking quick access to games without the hassle of installing new software. In contrast, our Game Hub offers instant playability directly in web browsers, removing the friction of app downloads and allowing immediate enjoyment, which is especially appealing to teenage demographic, which are known for favoring instantaneous access. Furthermore, Plateau has recently seen a decline in its reputation due to the removal of a popular feature that allowed users to earn coin through watching advertisements. This decision has upset a portion of their user base who enjoyed the benefits of accumulating in-game currency and accessories without monetary investments. In contrast, our platform maintains a user-centric approach, as we plan to offer different ways to earn rewards, ensuring our users feel valued and engaged without needing to reach for their wallets. Our last competitor is Game Pigeon, which is popular amongst people using iMessage as it integrates to the messaging function of iOS devices. This exclusivity significantly narrows their accessible audience. Our Game Hub, on the other hand, is platform agnostic, operating smoothly across all web browsers and devices, thus democratizing the gaming experience for a more extensive user base, not bounded by device type or operating system. Even though Android devices could technically download the app and play the games, the chat function is no longer available. Unlike our Game Hub, which requires no downloads and allows lifetime chat on any device. Our commitment to accessibility means that any user, regardless of their device, can dive into our gaming world, fostering a larger, more diverse community of players. This inclusivity is a cornerstone of our philosophy and is a key driver of our GameStone's universal appeal.
Hello, I'm Mark Aziz, and I'm another member of Budbusters. Today I'll be presenting our tech stack and the challenges we face with it. First of all, since we're making a web application, while we have some choices, JavaScript still reigns supreme in this department, with all its developed web frameworks. Though using JavaScript itself isn't such a pleasant experience mainly because of typing quirks. So we're using TypeScript instead, since it provides us with some type safety while still allowing us to use web frameworks that we want. Our main challenge here was learning TypeScript, though it was not too difficult since we had documentations which were clear and help from our teammates whenever we needed help. The frameworks we use for this project are React.js for the front end and Nest.js for the back end. React.js we chose since it's a popular framework and there were plenty of documentation and tutorials for us to rely on when we needed. We chose Nest.js because it's an Node.js framework based on Express.js, and thus it's simple enough to use, but allows us to still use TypeScript with very little pain involved, making it pretty ideal. We also use Socket.io for game communication, since using plain HTTP requests would be too slow. So we use sockets to communicate between client and backend during games, which allowed us to have better performance. We also used a library called TypeORM, which allowed us to interact with the database from our code base and store our objects for persistence with little else to manage. Speaking of databases, we also use PostgreSQL. Most of us are taking CSC 343, which uses it, so we were familiar with it and we had little issues setting it up and managing it. In addition to all that, we use NX to create and build our services, since it handles all the details for us and speeds up the process massively. It also lets us launch our application in a few steps, which also saves us time. And finally, we use Docker to containerize our services so that we can develop and test on the same environment and no longer have to worry about syncing environments whenever we make any changes. We can just update the compose file, and that's it. Our main technical challenges came with React because of the unique way it deals with UI and how the different components need to be structured and used. The way we've dealt with these problems is by further understanding the purpose of our components and exactly how much each one needs to do. And by analyzing this, we were able to use concise components, which made debugging much easier. We also had issues with Docker. Since we were using many services and each one was its own container, it caused performance issues with prolonged usage. But we noticed that a fresh reboot would substantially improve the performance of Docker, and that's how we've dealt with this problem going forward.